welcome to a new explainer. This explainer is gonna be a bit special. It's gonna have two parts. In the first part, I'm going to talk about the masterclass related to Fisher, the test of significance, and the p-values. And in the second part, I'm going to talk about the research report. Okay, as usual, I've got some questions. So this time I'm going to give you 4 questions and try to get the answers, then come back and we go through the answers together. So the first question is, what's the concept of population in Fisher? The second question is, what is a test of significance? The third is, why does Fisher use a null hypothesis when researchers are interested in the alternative hypothesis? So why the testing that Fisher proposes has to be about the null hypothesis? And the last one, and a very important one, what is the p-value? Now, those 4 questions capture everything we need to know about this masterclass. Okay, so let's start with the concept of population. Now, Fisher's conception of population has one part that is brilliant, and another part can be considered stupid. Why? So, Fisher considers that population is an abstraction. Population is about numbers, not about things. It's all about numbers. So, what's stupid about it? Well, why do you want to talk about numbers when what we want to know is about reality, not about numbers? So why does Fisher look stupid by proposing this population of numbers and not a population of the things we are interested in? In all the textbooks in research methods in psychology and social sciences, when you get to define a population is about people in general. All Australians, all female in the world, all children in Asia. So we get to define the population as people. Is that wrong? No, it's not wrong. But why does Fisher insist on defining population as a population of numbers? Well, because for many situations, if not all, in psychological research, we need to make abstractions. We are like Newton, Galileo, Kepler were when they had to deal with the motion of planets. Can they go to Saturn, to Mars, and measure how fast, if they move elliptically, and how fast they move around the sun? Can we even know how we measure, from the Earth to the sun to measure the distance? No, we can't. So Newton made an abstraction of the system, of the planetary system, and based on that abstraction he used mathematics to make predictions of where to find the planets if they follow what the mathematical model says, and then test whether the predictions are correct. But he cannot go and measure the speed of the planets by going to Mars, by going to Saturn. We need abstractions. So that's the brilliancy of Fisher. Yes, it sounds a bit strange that we talk about numbers and not about people, But that's makes things that are not possible to do it physically, to do it with a tool that makes an abstraction, and what based on those abstraction we can make predictions, and then we can test those predictions. So can we go and measure depression in all the people in the world? No, we can't. We can do it with a group of people, and then we can make an abstraction to that population. But there is another very important reason why we need to consider populations as abstractions, as numbers. Imagine this situation. I want to compare the performance of my lectures when I use PowerPoint slides versus the performance of my lectures when I use something else, not PowerPoint. And let's say I have a way of measuring, like asking students to rate my lectures in these different situations. Now, what's the population of interest there? Is it people? No. What is it? Well, it's a very difficult answer. Difficult question and difficult to answer. But Fisher gave us an idea. Imagine that, this is hypothetical, you give lectures with PowerPoint slides an infinite number of times, and you give lectures without PowerPoint slides infinite number of times. That is your population of interest. Okay, so why is this important? Well, I'm not interested about giving lectures infinite number of times. I have other things to do. But I am interested in knowing, on doing my job as best as I can. So I'm not interested to give one particular lecture better than another. I want to know, on the long run, what would be the best method of teaching. So, and here I'm going to disagree with Fisher. We don't need this infinity. That's his view of statistics is the frequentist view, and I support the opponent view of statistics, which is the Bayesian. But doesn't matter. The idea is brilliant. Then we can improve it. The idea is that we have to make that abstraction because it's useful to go beyond just a couple of lectures, the sample of that I obtain to measure my performance. Okay, so that is regarding the concept of population. Then the second issue is, what is a test? The second question is, what's the test of significance? Okay, so he used the case of the lady that tells that she can tell the difference between when the tea is served with milk first and then tea, or tea first and then milk. Now, the case he chose is a bit tricky. It's not the best one. But I wanted to show you, because I wanted to show how Fisher thinks and how Fisher developed the test of significance that every researcher in the world is using at the moment. Why is that important? Why not just tell you the method and that's it, easier? That's so important, because that method is being challenged. It's been challenged for many, many, many years. And it has a lot of flaws. But that method we haven't abandoned it yet. And we haven't abandoned it yet because a lot of researchers learned that in an automatic way without understanding what they were doing. And they made so many mistakes. And it is difficult to learn something different because they are used to do that. They think that what they are doing is correct. And they don't want to abandon that. They are doing what they were taught. And so it's so ingrained in teachers, lecturers at university, that the mistake gets propagated, and a critical mass of people are using a method that has problems without criticizing it. So even since the 1960s, there were criticisms to the method of Fisher, but it wasn't abandoned, and we still use it. Now, last year, the American Association of Statistics said that we should not use the test of significance anymore. Now, we are still using it. I'm not using it, but most researchers in psychology are still using it, but it will take a few years and I think it will be abandoned. But what do we use instead of the test of significance? Well, we need to use other things. But whatever we do, we shouldn't make the same mistake that we adopt a new method without thinking about it. So that's the reason why I wanted to show you the thinking of Fisher, of how he came to what he's doing, and because it allows us to understand what's brilliant and what's wrong. Okay, so the test of significance. What he said is that we need to develop a test. We need to consider all the possible outcomes of that test in advance. That's brilliant. And then, before we run the experiment, or we run the test, we need to determine which of those results we are going to consider that we obtain a significant effect, and which results we are going to determine that the effect was not significant. So in the case of the T lady, well, we are going to determine that there was an effect, that the lady really can tell the difference only if she gets the 8 classifications correct. If she gets 6 or less, and 7 is impossible, we are not going to say that the test was significant, and therefore we are not going to accept that the effect is true. So that's brilliant. We plan the experiment, we envisage all the possible outcomes, and before we run the experiments, we know what we are going to judge, how we are going to judge all these outcomes before even we run the experiment. And that's a brilliant thing to do. Now, the third question was why we have to use a null hypothesis, why Fisher proposes a null hypothesis and not why to test the alternative hypothesis. And this is a technical problem. And he came up with this solution that It's not the best. But again, he came with to this solution because the problem is very difficult, and he acknowledges the problems. So what's the real problem? What's the problem that Fisher was facing? The problem is this one. Let's say we know all the elements of a population of values, and we know how they are distributed, these values. Let's say we know these values are distributed in a normal, they follow a normal distribution. And remember, we're talking about infinite number of values, so if we say that there is a normal distribution, the normal distribution is a perfect curve. So if we know that, then we can determine in advance what's the probability of observing any value if we take one value randomly from that population. Why do we want to do that? Well, we want to do that because that's what we do when we do research. We extract a random sample from a population and we do some measurement and we obtain a value. Typically, we calculate the mean of that sample. So now, if we know the population, it's easy to determine the probability of observing a value in a sample. But the problem is that we don't know about the population. We don't have the measurements of all Australians, of all children in the world. We don't have those measurements. What we have is samples. And we have to do what is called inverse probability. So from the samples, we need to determine, we need to make an estimation of the population. Okay, so that's the problem. When we have a population, we know the population, we can deduce. By deduction, we obtain the probability of observing any value. But when we have a value in the sample and we don't know about the population, it's extremely difficult to make an estimation of the population. Very, very difficult. That's the inverse probability. Well, the Bayesians, starting with Bayes and then Price and then Laplace, were proposing to do inverse probability. We are not going to go through that method. It's quite complex. But the problem of that method is that it wasn't working when they proposed it. It wasn't working because the calculations to use those methods are very, very expensive, computationally expensive. So in those days, it wasn't possible to do the analysis that you're required to do. But today we can do it. So in the last 10 years, the power of computers can allow us to use those methods. So it's going to take some time, but those new methods will be the rule at some point. But so because in those days that power wasn't possible, it wasn't there, then Fisher had to come up with another idea, something that the researcher can use in their practice. And the idea was to imagine a population in which one specific value is true. So I'm going to draw it here. Population, which a value, the mean of that population is 0. Okay, so what's so special about 0? Well, nothing special, but the idea of Fisher is that we need to make that decision of starting with a population with some value. Now, 0 is a convenient one because sometimes we want to compare two groups. And the null hypothesis is that the difference between these two groups is 0. So that's a good and interesting value. Now, why don't we use 2, for example? That the difference between these two groups is 2. So one group has 2. The mean of one group is 2 points higher than the other. We can do it, but we can, if we start doing that, then we can use 2, 3, 4, 5, minus 2, minus 5, minus. It becomes impossible. We can do it now, but they couldn't do it in those days. So he came up with the idea to say, well, let's consider that the null hypothesis is true. A hypothetical population in which the null hypothesis is true. And then from that, we can determine probabilities of obtaining samples. So, but you may think, well, but why do we want the null hypothesis? We want to test whether the group that receives a psychotherapy gets their depression gets reduced more than the group that doesn't receive psychotherapy. So that's the alternative hypothesis. That's what we want to test, if it's true or not, because we want to decide whether this new psychotherapy is useful or not. Why the null hypothesis? Well, because, as I said, we cannot say what is that the one psychotherapy is better than the other. Is it that it gets a difference of 1, a difference of 2, a difference of 3, a difference of 4 or 5? We cannot be exact about it. So let's start with the null hypothesis, and from there we decide which results in our study will be so different than what you expect if the null hypothesis is true, that we reject that idea. And if we reject the null hypothesis, that supports the alternative. So that's what Fisher, he had that dilemma, and he came up with a solution. Okay. The final question is, what is a p-value? And a p-value comes from the null hypothesis. So in order to calculate a p-value, what you need to know, we need to start with is with a null hypothesis. So you imagine, you consider, you assume that the population you are interested in, the null hypothesis is true. So there is no effect. The psychotherapy, the new psychotherapy, is not better than no psychotherapy. So that's the assumption. Okay, so then you obtain a sample. And let's say that the improvement that you observe, here is the sample. I'm going to change color, and you observe that this is the difference that you obtained. So here is 0, here is 2. So in the new psychotherapy, on average, is 2 points higher than the other one. Well, does it mean that that is better or not? Well, Fisher says, let's consider that in the population, we've got a population of values which the mean is 0, and it has some standard deviation, and we start obtaining random samples from that population, and we calculate the means. Okay, so first question, what's the size of those random samples? Well, the size should be the same as the sample that you collected in your study. Why is that? Well, because what Fisher envisaged is that we need to simulate that we are doing the same as that the researcher has done. And that sample that the researcher obtained could be one of infinite number of samples that we could have obtained from that population of values. Okay, so that's the idea. So then what you do is you obtain one sample and you calculate the mean. Okay, so I'm going to do it with another color. So let's say I'm going to put here that distribution of means. So first sample, I obtained the sample size is the same as the of my study, and the mean of that is around here. Okay, second study, obtain this one. Now remember, these samples are obtained from this population. So what will happen is some will be close to 0, some a bit farther away from 0. But if you do this long enough, then all these means will be concentrated around 0. So most of them will be close to 0. So basically, if you develop a distribution of the means of those samples, then you have a distribution that is a normal distribution. But the difference with the distribution of the population is that the standard deviation, the standard deviation is much narrow. How do you know that? Well, look the dispersion of these values. So here we still have some values that are quite likely. Same here, but here on the bottom of that distribution, these values are almost 0 already. So this is a much more narrow distribution. So I clarify again. This distribution is population and is raw values. And this one is a distribution of means. So that's called the sampling distribution of the mean. Okay? Now, so that sampling distribution of the mean is a sampling distribution. So it's a distribution which comes from a population in which the null hypothesis is true. So in a population in which there is no difference in two groups, sorry, in a population of values in which the mean is 0. Okay, so now we compare with the value I obtained, and the value I obtained here is 2. So what we want to know is, and here depending on how we propose, how we defined the alternative hypothesis. So if we said that we expect that in our sample we will obtain a value different than 0, and we want to know whether that value, so whether we want to whether our value is different than 0. So basically I'm saying here different is the word that is important. I'm not saying that the value will be higher than 0. I'm saying that it's going to be different. So if I say that it's going to be different, then I have to look at 2 and I have to look at -2 as well. And I have to look at these two tails of this distribution. And basically that's the p-value. So all the probability that of obtaining a value of 2 or higher, and a value of -2 or lower in that sampling distribution that comes from a population of values that have a mean of 0. Now, if that probability is not too low, and we have to decide in advance, a typical significance level is 0.05. So if it is not lower than 0.05, so we say that, well, perhaps the number 2 we obtain in our study still comes from a population in which the null hypothesis is true. It's just by chance we obtained a value of 2, but it could have been -2 or anywhere between those, between 2 and -2, and still come from a population where the null hypothesis is true. Now, if the probability of obtaining 2 in that in this distribution is, the probability of obtaining 2 or higher, or -2 or lower, is lower than 0.05, then we say, that's a very low probability, so I reject the idea that this value 2 came from this population and this sampling distribution. Okay, so why 0.05? Well, Fisher proposed 0.05. And everybody else followed what Fisher said and started using that value as a threshold. But Fisher said that just passing by. He said, well, 0.05 could be a value. He didn't say that there is anything special about that value. He said, well, let's use this value. No other consideration whatsoever about that value, why that value is important. So, but most researchers follow, especially in psychology and social sciences, followed that advice as if it was some mysterious law of nature, which is not. It was an arbitrary number. Okay, so, but that's what a p-value is. if our hypothesis was that in this case is justified to do it that way, that we are going to obtain a higher value in the therapy group rather in comparison to the group with no therapy, then we only looked at this at the right side of this distribution. So we don't look here. We look only at the right side. Why is that? Well, because we don't expect, if we say that there is a difference and we don't establish whether it is higher or lower, then we expect that could be to one side of the mean or another side of the mean. But if we said that we expect that the value is higher than 0, or that there is a difference in favor of the group of the therapy, then we don't care about negative values. So we look only to the right hand side of the distribution. So the p-value is still the same, but instead of saying that the p-value is the probability of obtaining a value, the value that we obtain in our sample, or higher, that's it. That's the p-value in this case. We don't have to add or more extreme. So we should have, that means that we need to go look at the other side of the tail as well. Okay, this finalizes the 4 topics that I wanted to talk about in this explainer.